In this video, we'll look at solving quadratic equation by factorization when the leading coefficient is not 1. As you know, the general form for quadratic equation is ax squared plus bx plus c. In the previous video, we looked at the case when a is equal to 1. Now we want to consider the case when a is not equal to 1. So let's start with an example. So let's say you have 2x squared minus 14x plus 24. You can see that the leading coefficient here is not 1. So the first thing we need to check is to see whether we can actually reduce it to a quadratic with a leading coefficient equal to 1. The way to do that is to look if we can take a common factor. And the best thing to do here is to see if we can take the leading coefficient as a common factor, because that automatically will result in a quadratic equation with a leading coefficient of 1. In this case, the leading coefficient is 2. So we need to see whether this 2 can be taken as common among all the terms. So 14 is divisible by 2. 24 is divisible by 2. So then 2 can be taken as a common factor. So this quadratic can be written as 2, and then we have x squared minus 14 divided by 2 gives you 7x. 24 divided by 2 gives you 12 equals to 0. Now what we have here is a quadratic with leading coefficient of 1. So we can use the technique that we learned in the previous video to factorize this one. And if you're not familiar with how to factorize quadratic when the leading coefficient is 1, please check the previous video on the channel to see how to do this. So if you follow that technique, actually this is one of the examples in the video, you will see that this can be written at x minus 3 times x minus 4 equals to 0. And so the solution to this quadratic is simply either x minus 3 equals to 0 or x minus 4 equal to 0, or in other words, x is 3 or x is 4. Now this is the case we are lucky and we can factorize some common number. Now let's look at the cases where this is not possible. We cannot take a common factor. So let's look at an example. 2x squared minus 5x minus 3 equal to 0. Again, we can see that the leading coefficient here is not 1, it's 2. So the first thing we check is, can we take this as a common factor? Now immediately we'll see that 5 is not divisible by 2, so then we cannot do that. We need to solve this using the technique that I will explain to you. What we'll do here is to look for two numbers. So we are looking for two numbers. And these two numbers, they need to satisfy two things. First, their product is a times c. So 2 times minus 3, this gives you minus 6. And then their sum should equal to the b coefficient, which should equal to minus 5. So we're looking for two numbers. When we multiply them, give us minus 6, and when we add them, give us minus 5. Since the product is negative, it means we are looking for two numbers that have different signs. So we don't need to consider numbers that have the same sign. We look at minus 6. How do we get minus 6? You can have minus 1 times 6. You can have minus 1 times 1. You can have also minus 3 times 2 or minus 2 times 3. However, we are looking for two numbers that add up to minus 5. So the one that will give us minus 5, minus 6, and 1. Then what we're actually trying to do is that we're trying to write this middle term to a sum using these two numbers. So this will be minus 6x plus x. So we did not actually change anything here, because when you add these, it will give you back minus 5x. Now let me show you the box method to get the factors for this quadratic. So the box method, we create a box 2 by 2, and on this square here, we write the x squared terms. So here we write the x squared terms. In this case, it's 2x squared And in the lower right corner, we write the C term. In this case, it's a -3. And then we have the two other square left, and these we will use them to write these two terms here. So I can write here minus x and here x. You can also swap the order. You can put x here and minus x here. It doesn't matter, it will work. Now what you need to do is the following. You need to look in each column and see if you can find any common factor between the two terms. So you're trying to look at this column here and see if you can find any common factor. So let's look at the numbers. We have 2 and -6. Definitely we can take 2 as common. So let me write it here. And then x squared and x, I can take x as a common factor. Then you can look also at the other column here, and you look between the x and -3. Now, it seems that we don't have anything common between them. In this case, you just write 1. Then, we also look at the rows. So we'll take the first row again, and we do the same thing. We look at anything common between. So for the numbers, there is 2 here, and there is 1 here. So it's simply 1. And then x squared here, and x here. So we can take 1x, or x simply, as a common factor. And then this one, you have -6 and 3. So just take always a positive number as common, and then later on we'll fix the sign. So don't worry too much about the sign now. We'll fix the signs later. So if we look at 6 and 3, what's common between them is 3. Okay, let me take a quick detour here to explain to you how we're gonna fix the sign. So we already reached this point where we have terms inside the box, and these are essentially coming from the original quadratic equation. And we also get these terms outside the box, which we get them by looking for common factors between the terms in each column and in each row. Now, if we did everything correctly, we should be able to get any term inside the box by multiplying the terms outside that are on the same row and on the same column. So for example, if we take this one, 2x squared, this is in the first row and first column. So if you multiply the terms outside the box that are in the same row and same column, which is 2x and x, if you multiply them, you get 2x squared. So we are getting correctly the term inside. In general, we should always get the term inside, except for maybe the sign, which we need to fix. And the issue of the sign coming because when we're taking the common factor, we ignore the minus, and now it's time to fix it. To organize the process, I'm gonna make a tick to this term outside. So this to remind us that we already used these to produce term inside, and we should not touch them. What we will do in general, we'll need to add a minus sign for some of the terms outside. Since we already use these to produce a term inside, we should not add a minus sign. Otherwise, we'll not be able to produce the term inside. For example, if I add minus here, it will be minus x times 2x. This will give me minus 2x squared. So that's why I put a tick here to remind us that don't touch this term anymore. Now, if we look at another term like this one, minus 6x, again, we should be able to produce this by multiplying the terms outside on the same row and the same column. So if you look, we have 2x times 3, that give us 6x. Everything is correct except for the sign. And here where we need to add extra minus sign to one of the terms outside. Since we have a tick for this 2x, we'll not touch it as we said, because we already use this to produce a term inside. So changing it will affect that term. And this one, there is no tick next to it, so it's fine. We will add a minus sign here. And then we'll have minus 3 times 2x give you minus 6. So this is in general the steps that we have to follow to fix the sign by checking for every terms inside and see whether we need to minus sign. However, we need to be organized once we take a term. We need to remember not to modify it. Here, I'm going to use a tick, as I said, just to emphasize this point. Okay, so let's go back to our example and complete. Now let's go back to fixing the signs. If we look at this term here, this term is coming from multiplying the term in the first row times the term in the first column. So 2x times x give us 2x squared. So this is fine. We don't need to do anything. It means these are fine to keep them as positive. Then if we look at this term here, so this is coming from multiplying the term in the first row times the term in the second column. So x times 1 give us x. So this is already, we said we'll make it positive. So we'll not touch it again. This one, we also need to keep it positive to get this positive. Now, let's look at this one. Here, we have minus 6x. And already we have 2x. And then we need to multiply it by 3. 3 times 2x will not give us minus 6. So this one has to be minus. So this one is a minus 3. And then we need to check here. Already we said that we'll make this minus. So minus 3 times 1 will give us minus 3. So everything is fine. Now what are the two factors? The two factors, you get them. One, get it from here. This one be 2x plus 1. And the other one will get it from here, which is x minus 3. Remember the minus that we add, fix this. So then our quadratic, which was 2x squared minus 5x minus 3 equals to 0, we can factorize it as 2x plus 1 and x minus 3. You are multiplying two numbers. Remember, x is just a variable, so when you substitute a number, you'll get two numbers. This is 1 times the other one. So one of them has to be 0 if we want to get 0. So either 2x plus 1 equal to 0 or x minus 3 equal to 0. From this one, you can see that 2x has to be minus 1 if we subtract 1 from both sides. And from this one, you can see that this one is equal to 3. And here, if I divide both sides with 2, you'll get minus 1 over 2. And this is 3. So these are the two solutions. X equal to minus half and x equal to 3. You can always check this as we did in the previous video by substituting back the value of x on the original equation here. And if you substitute, you should get 0. If you didn't get 0, it means you make a mistake. Okay, so that's a step if you want to verify if you did everything correctly. Let me give you another example. So let's put 6x squared minus 7x plus 2. Again, we can see that the leading coefficient here is not 1, so we cannot apply the technique that we did in the previous video. And then our next question to see whether we can take something common between these terms to make the leading coefficient 1. If we try to divide by 6, 7 divided by 6 will not work, so we cannot again also take a common factor to reduce it to a polynomial with leading coefficient of 1. Then, as we did in the previous example, then we look for two numbers. Their product should be 6 times 2. Okay. So this gives you 6 times 2, which is 12. So the product is always A times C. We are looking for a product A times C. And then the sum will be always the B coefficient. So this is the B coefficient. We can see here that the product is positive. And again, positive product means that either the two numbers are positive or both of them are negative. Since the sum is negative, then both numbers that we should consider are negative. We can look at ways to get 12. We can have minus 1 times minus 12. So whenever the signs of the two numbers are the same, you don't need to consider the order. So you don't need to consider minus 12 times minus 1. It doesn't matter since the signs of both are the same. But when the signs are different, you need to consider it. And then I can have minus 3 times minus 4. I can have minus 2 times minus 6. So these are the different ways to get 12. In order to get minus 7, we can see that this one, when we add that minus 3 and minus 4 give us minus 7. And what we'll do, simply that this term, middle term, minus 7, we can write it now as 3x minus 4x. And then we can create the box as we did in the previous example. So this is a 2 by 2. And again, on this square, we write the x squared term. And here we write the constant term, or the c coefficient. The remaining two, we use them to write these two terms. And we can put them in any of the two boxes. We use them to write these two terms. I can say here minus 3x and here minus 4x. It doesn't matter if you put minus 3x here or minus 4x here. It will work fine. So you don't worry about it. Now again, as we did, we look at the first column and try to see if there is any commenting. Again, don't worry about the sign. We'll fix the sign at the end. So if we look at the number 6 and 4, we can see that we can take 2 as a common between them. And x squared and x, we can take x as common. We look at the second column again here, 3 and 2, we cannot see anything common. And in this case, we put 1. So whenever we don't see anything common, just put 1. We look also at the first row, we have 3 and 6. We have the 3 and 6. Again, the sign will fix it later. So 3 and 6, I can take 3 as common. And also we have x squared and x. I can take x as common back. If we look at the second row, we have 4 and 2. I can take 2 as common. And now we go back to fixing the sign. 6x squared, we will get it by multiplying the element in the first row times the element in the first column. So 2x times 3x. 2 times 3 is 6. X times x give you x squared. So it means the signs, keeping them as positive is fine. So I'll make a tick here to remember that these signs are okay. And whenever you make a tick, you will not change these later on. Because if you change them, you are creating a problem. So whenever we fix the sign for 1, we'll keep it. And if we need to introduce a minus, we will use the other terms that we haven't fixed its signs already. So if we look at again this term, this we get it by multiplying the first element in the first row times the element in the second column. So 3x times 1. Now we can see we have a problem because there is a sign here. Since we already fixed this to be positive, we'll not touch this one. In other words, we'll introduce the minus here. And let's go this one now. This we get it by multiplying the element in the second row times the element in the first column. So 2 times 2x give us 4x. Again, we have a problem with the sign. This is a negative. So in order to fix this, we already fixed 2x to be positive, then we'll change the sign here. So we'll make this minus. And this minus will fix for us the sign. We need just to check this one to make sure that it's correct. So this we get it by multiplying the element in the second row times the element in the second column. So minus 2 times minus 1 give us 2. So that then these are fine. Now our coefficient, we get them from here. We take this as one coefficient. So we'll get 2x minus 1. And then I can also get the other coefficient. Yeah. This is 3x minus 2. Now, our quadratic that we started with is this one. I can write it as 2x minus 1, 3x minus 2 equal to 0. Again, one of these two coefficients has to be 0 in order to get 0. Then we have equal to 0, or here I add 1 to both sides, so I'll get 2x equal to 1, or I add 2 to both sides and I'll get equal to 2. I divide here by 2, so I get x equal to 1/2, or I divide here by 3, I get x equal to 2 there. And these are the solution to the quadratic equation. Again, if you want to verify, what you will do is you can take this and substitute back and see if you get 0. If you get 0, it means your solution is correct. Again, you can try with this one, substitute for x on this quadratic equation and see if you can get 0. If you get 0, then your steps were correct. Finally, if you find this video useful, please give it a like and don't forget to subscribe to the channel and turn the notification on so that you get notified about new content. Thank you for watching.